Buenos días. Ahora tocaría el keynote. Lo digo porque veo que hay gente que sale de la sala. Good morning, everybody. Now it's time for the keynote speaker of the second edition of the Big Data Congress, Alexander ISAKOV. As an innovator entrepreneur, Alexander has experience moving from concept to company. For example, he invented a surgical device, founded and spun out a company from Harvard, and raised seed and Series A funding at $1 million valuation as CEO of Lattice Surgical. As a Harvard-trained scientist, he has published papers on cross-disciplinary topics without regard for traditional boundaries of discipline. For example, he studied how decision-making is mediated by social networks, how institutions can promote cooperation, and how complex systems synchronize on evolving networks. He forged a number of collaborations with well-known scientists across multiple universities and has led multiple teams of researchers. One of his current board scientific interests is the interplay of cultural evolution and network and how this leads to real-life decision-making, including in business environment. In his talk, Innovation-Driven Thinking, a running disruption through 2020, we will discuss 5 macro trends at the interaction of business reality and technology. Through case studies, we will learn why innovation-driven thinking is necessary to remain ahead of the curve. Alexander ISAKOV, welcome. Thank you for being here. The stage is yours.
Excellent. Good morning, and thank you all very much for coming. And Mark, thank you for the very generous introduction. My name is Dr. Alexander ISAKOV, and I'm the CEO currently of Pallantius, a data-driven management consulting firm focused on measuring and improving operating velocity in the banking and finance industries. So here's the obligatory slide for today. What is the mantra in the corporate world today? We need to use big data. You know, it must be true because of the big red letters and how many technical words there are kind of in this word cloud. But what can be better than big data? Clearly, huge data. And you can tell that because of the even bigger red letters. Well, if this isn't how your company works, don't worry. I still have a very fun talk for you. So today, whether you're a digital officer or the CEO of a large company, I want you to engage in thinking like an entrepreneur, or what I call innovation-driven thinking. Before we discuss trends in technology, let me frame the discussion by stating a very obvious, but very often forgotten fact. Real life isn't about the size of your data or how advanced your technology is. The truth is, data is easier to get than ever before. For many years, the most ardent wish of many CEOs and other leaders would have been to have any technology that would allow them to collect some additional tidbits of information about all of their customers, employees, and competitors beyond the rudimentary. Technology, as you know, is pushing that boundary. Now, we seemingly carry this technology in our pockets. How many of you, and on our wrists, actually. So how many of you have seen a screen? Nope. Oops. There is no laser, is there? Okay, it doesn't matter. How many of you have seen a screen like that on the top left there? And how many of you, at least once, have pushed that button without reading any of that text up there? I know I have. The truth is, almost any app can know what you're storing on your phone, where you go, and take pictures and videos. Your watch can know your heart rate, the weather, and whether you're exercising or whether you're sleeping in class. And as businesses, we are privy to this information. Our employees work more and more with digital tools, which allows us to better understand them, even if you have 10,000 or 100,000 employees. And all companies now put their information on the internet, where it gets aggregated so you can learn about your competitors. In short, it's very easy to be inundated with data. It's hard to ask useful questions and use technology appropriately. How do you get business value from data and technology? By asking the right questions. And how do you ask the right questions? You practice innovation-driven thinking. And really, technology is here to facilitate this. So let me use this half hour, or what's remaining of it, to show you 5 trends in data science and how they are, or maybe should be, or should not be, affecting your business. So this is our journey today. In this talk, I want to accomplish just 2 things. One is to provide a compass to help you find where the world is going. For this, we will see an example of how data science is driving the evolution of several trends in both technology and thinking. Some will be useful to your business immediately, Some will be in the future or in the near future, and some might not be quite right for you. I'll be sure to give some unsolicited advice along the way. The second point is a little more subtle. I want to convince you that no matter what I say today, you can safely ignore it. No matter how much you agree with me, what I will present here is just a guide, the way I see the world. Innovation-driven thinking is a broader philosophy that forces us to think about how we can do better than we're doing now and can allow us to outrun disruption. Hopefully, by showing you where the world was and where it is going, I will inspire you to come up with your own take on innovation. So let's dive in. The first technological trend I want to discuss is algorithmic sophistication and how this gets coupled to business processes. The main idea behind this is very simple, and you've heard a lot about this today and yesterday. The step before technological advancement is ad hoc or gut feel solutions to problems that could be solved with data. In the worst case, the solution to a problem is what Amazon would call a hippo, the highest paid person's opinion. In yesterday's talks, you presumably heard about how valuable data is as an input into data science, which leads to better decisions. Indeed, there has been a strong, steady progress towards acceptance of this idea at a number of companies, including, I'm sure, many of yours. With the data science approach, you can answer questions more accurately, faster, you can look across an organization, and so on. However, as some companies become more and more comfortable with this, especially in some divisions, a new technology trend needs to emerge, one that provides not only fast answers, but creates integrated systems of action. After all, what if I tell you that a particular transaction may be fraudulent? Oh, basically just not. Excellent. But your investigation team is swamped and has a multi-month or multi-year lead time for queries. Or what if they never even know about it, even though I told you or the technology told you? As businesses realize that the news speed for getting insights is not months and years, but weeks, days, and hours, there is a growing need for technology to start wrapping the insights that they're getting, the insights that the data science teams are getting, into more rapid processes that are then actionable. So let me give you just one concrete example of this. Fraud detection, just because it's fun. Detecting fraud is a big deal, both internally and externally. The problem is especially large in financial services, as you can imagine, including credit cards, banking, and insurance. Credit card fraud amounts to over $13 billion in the US annually. But for a particularly interesting example, let's turn to the insurance industry to see how algorithms and processes are working together. Medicare is the United States federal health insurance program for people who are 65 or older, as well as certain other groups. The details don't really matter for us. For Medicare alone, in 2014, the Centers for Medicaid and Medicare Services estimate that $60 billion was lost to fraud, waste, and abuse, and improper payments. $60 billion. Let's take a look at how an innovation-focused approach, coupled with new processes, is working to help reduce this number. Here's how things were done before. Namely, very, very, very slowly. Uncovering fraud was very slow, was inconsistent, filtering through claims took forever, and often fraud would be caught years after it had occurred, long after all the money had vanished and sometimes the people also. As a result, despite large amounts of resources nonetheless spent on prevention, only some typically small percentage of the charges was recovered. Essentially, this is the traditional pay and chase method. Clearly, the old way wasn't working very well. So, innovative technology efforts in the form of both new algorithms and new processes are being put in place to combat these more efficiently. So now, we can hopefully get a bit closer to this. The director of CMS's study, Center for Program Integrity, explained how they started using advanced analytics to identify fraud early, and, importantly, the process pipeline they created. The new Medicare approach has 4 prongs for fraud detection. Each part addresses the challenge by having an easy-to-understand idea. The first is a rules-based model that uses common-sense cutoffs and cross-verification to detect obvious cases of impropriety. The second is an anomaly model that detects highly suspicious behavior, such as doctor billing anomalies and so on. The third is a predictive model, some of which we'll hear more about today, that focuses attention on billing practices that strongly resemble past fraudulent activity. And then there's a model that looks at social networks and healthcare providers that are connected to others engaged in fraudulent activity. In 2016, these technologies led to over $1.5 billion in identified fraudulent payments. But part of the success, a large part of the success, isn't just from the ability to flag fraud quickly, but in having the ability to coordinate between insight and action. For example, The fraud protection system identified a home health agency that billed for services that were never rendered using this kind of big data system. From this insight, they placed the home health agency on prepayment review and payment suspension, referred the agency to law enforcement, and revoked their Medicare enrollment kind of through an automated process. Whereas before this could go on for years, despite knowing that someone was committing fraud, due to the ability to coordinate between data and action, it could be stopped very quickly. So I don't have time to go into other examples like this, but I'm sure you've heard many of them already, and you can hear many more at the nearby IDB conference in a couple of days. I would say developing new algorithms for specific industries is in the process of being solved for a large class of problems. However, not all are integrated with downstream processes, including automated systems that raise flags and perform other actions across business units. If I had to give a score of how much you should pay attention to this, it would be definitely 5 out of 5. Very important for all businesses here. The second trend I'd like to discuss is a bit more technological. It's data lakes. As many of you know, storage costs have dramatically decreased over the last few decades. The cost of a gigabyte of storage was $1 million 30 years ago, and by 2011, it's about 20 million times cheaper at less than 5 cents. The last few years have led to even more efficiencies, with a 40% price reduction for using cloud storage solution, among some other kind of technical things. So we can store a lot of data. Not everything, of course, but a lot. So then the business question is, who has access to it? Before, the trend was that particular business units owned this data and they were very protective of it. In fact, this is still a trend I see today. I was just recently in Germany talking to a bunch of big banks, and this is the way it's done in many companies. However, an emerging and maturing trend now is pulling it all together and storing it centrally. The main idea behind the concept isn't totally new. So-called data warehouses have existed for years, but now people are moving towards the data lake. The main difference here is technological. Data warehouses are a mature technology. The idea there is to store standard structured and processed data in a predefined and fixed format in a central repository. But recently, people are, as I said, moving towards the data lake idea. This is a similar idea, but for storing not only predefined structured data that can be arranged in tables like numbers, but also unstructured data like freeform text, website clickstreams, location, as well as demographics and other traditional data, combined with this modern data. Then, the idea is that this can be tapped into and used at will for appropriate business processes by either business people or data scientists. So let's see how this can help in practice. So our friend here is back. So according to a leader in the smart metering division at a leading Canadian utility, they had losses of about $100 million a year due to theft. It was expensive and hard to detect without zeroing in on it at scale. So they rolled out almost 2 million smart meters, feeding that data, and including geospatial data and personal data, into a data lake where it can be analyzed and used across units. Note that this is not all traditional data. It's also a stream of voltage readings and geography and kind of anything that a utility company might be collecting. This method is helping them achieve its goal of theft reduction, but importantly, is also being rolled out to not just be used by the anti-theft team. Since the data is in one location in a data lake, it can also be used for other purposes, like understanding the customer and doing better marketing. But of course, there are significant challenges with this. The trend towards data lakes is still maturing, and many organizations simply do not have much of the type of data that would benefit the most from creating a data lake. In fact, I've had a lot of CEOs say, we'll create a data lake next year, we'll spend $100 million on it, and I sometimes say, why? You just want to store customer names and their credit card numbers? Doesn't make sense. So ultimately, you have to decide what business problem it is solving before committing to a costly implementation. Part of this is ensuring that the data lake doesn't become a so-called data swamp like that, a place where it's easy to drown in the data and make it even harder for teams to get insights due to the volume of information and the lack of coherent structure, coupled with kind of a lack of talent in using this information. For example, I've seen people try to start dumping in thousands of disparate tables from many sources and users from around the organization making various demands without the right infrastructure in place, which ended up with much more frustration and much less functionality than they started with. Technology-wise, there are also a number of concrete challenges. For example, a successful data lake needs domain specification, and no vendor, at least that I know of, maybe will be proved wrong later today, offers a good one-size-fits-all off-the-shelf solution. For example, you might need company-aware capability to map particular company terms to physical data in order to allow users in the company who speak that language, basically, to navigate and explore the data. And these tools should be usable outside of the IT so that the lake is useful to both data scientists and the business people whom it was meant to help. At the same time, it has to be flexible enough to be able to easily ingest new content and new types of data, and so it has to be easily configurable. Further, as the whole idea relies on capturing a large collection of attributes for all the pieces of content, you need to maintain strict quality controls and tracking. This in turn requires a very large amount of automation to be feasible, and it's hard because of the disparity and potential underlying messiness of the sources underneath, the data sources underneath. So not to mention integration with the current, often poorly version controlled data that's at the base. So many companies so far have taken several years and millions of additional dollars to configure a real data lake. And I would say that unless you have large sources of non-traditional data that can solve concrete and present or very soon to be near future business challenges, you can likely just be aware of and watch this trend as it evolves, waiting until it becomes easier to implement and more likely to fill a need within your broader business culture. So I'd say the current relevance to most of you of data lake technology is probably around 3 out of 5. So now let's talk a little bit about data privacy. This is becoming more and more important both in the US and in Europe, but especially in Europe. So here, there's a large and very rapidly growing data protection legislation, as I'm sure many of you know. This disallows, among a number of other actions, some special categories of processing, collecting data without a pre-specified purpose, and in some cases, sending data overseas, especially to countries where there might be government spying, like the US. The benefits are that customers can have more control of their personal information, and they can prevent misuse. And it can reduce damage from leaks or hacks. But there are also very serious challenges. One is that it might not be clear what you need at the outset, and the lack of historical data can make later hypothesis testing very challenging. Thus, one worry is that there is a trade-off between privacy and innovation or experimentation. However, the reality is that privacy is important to maintain consumer trust as well as to prevent litigation. In other words, to protect your bottom line. So one way to maintain innovation is to have a fully fledged strategy of experiments lined up that align with concrete business problems. So I keep returning to this phrase, concrete business problems. Thus, you need to have experience navigating the waters of what is strategically possible with big data before committing to careful collection and utilization, and then also have privacy technology in place. So, of course, data security is important for all organizations to prevent wrongdoing, but let's talk about an application. The idea is that new technology allows sources of information to be used in many different ways outside of the reason for which they were collected, especially when coupled together, either on purpose or accidentally. For example, let's take a look at a smart thermostat like this. It's easily controllable and can store and transmit the temperature a user wants. Okay, a very nice product, maybe if you can use it for your business if you have something that needs to track the consumer in their home. This is very, very convenient. But such a sensor that was used to provide additional convenience could also be misused. For example, readings with the user's demographic data and other identifiers such as geolocation data can tell you when someone is using a house. Again, using big data algorithms, you can probably very easily predict when someone is using it and looking at historical trends when they will be using it. If an insurance company gets this data, they could couple it with their own internal data and potentially raise your premium. For example, because you aren't home very often and this increases the risk of home burglary. And how many of you would think about insurance when buying an automatic thermostat? Or about the possibility of home invasion if that data gets leaked? So a robust privacy strategy and data protection strategy centered on technology is mandatory for any business that deals with customer data, and the sooner the better. This is especially important as you increase your own reliance on data, implement new technologies, and propose new methods for extracting value. Thus, there are 3 major challenges. First, the innovation privacy trade-off, where more data can provide better insight, but can also leave users much more vulnerable. Second, being aware of the regulations on collecting, storing, and using information, which are changing as we speak, requiring both new strategies and new technologies to remain compliant. For example, you might not be able to store certain information on Google servers in the US or on the cloud if the servers are somewhere in a country where it's not allowed to transfer your data overseas. And thirdly, there's the danger of exposure of even seemingly innocuous information, which can be combined externally for additional and possibly malicious purposes, which can cause significant brand damage. In short, the danger is that customer information, which they willingly give to you, can be misused against them if privacy measures are not in place. So I would say that putting the technology in place to provide excellent security and deal with breaches is critical in order to both provide protection to your firm and to maintain your customers' trust. So the relevance of this trend, I would say, is certainly a 5 out of 5 for all businesses here. Now let's move on to some more fun and futuristic stuff. Here I'll talk about human-AI interactions. On both the data science and the technology side, as you've heard and as you will hear, a growing trend is dealing with much more complex questions than we could have done before. Some areas with large improvement are smarter image, sound, and text identification, and search and response, dealing with so-called unstructured data. For example, can we automatically learn who the person in an image is and what they're doing just by looking at it? And then also, can we recommend an action based on that? Can we have the computer understand spoken natural language queries and also reply to them and also recommend an action on top of that? It turns out that the answer is getting closer to yes, and that this is very relevant, or I think will become very relevant to many businesses in the near or potentially medium-term future. So let's take a look at an application. There are a number of programs that try to simulate human-AI interaction, and some are gaining traction as additional automation in customer-facing roles or in standalone services. These areas will continue to improve rapidly, and the field of applications is expanding dramatically. Some, which you've probably heard of, like Microsoft's Cortana or Apple's Siri, or actually even SoundHound, will ultimately get very, very good at interpreting human requests and replying appropriately, including performing tasks and allowing you to integrate this into your product streams. For example, here is a video of how SoundHound works.
Okay, Hound, what is the monthly payment on a $700,000 home with 20% down over a 30-year period, assuming a 3.9% interest rate?
Your monthly mortgage payment is $2,641.34.
How about with an interest rate of 3.6%?
Okay, using an interest rate of 3.6%, your monthly mortgage payment is $2,546.01.
And you should buy it from my insurance company. No, I'm kidding. But there are also significant challenges in businesses using the technologies, right? So this is pretty cool. One challenge is that much of this is specific use case technology, unfortunately. For example, X.AI for scheduling meetings automatically through email exchange. So it looks at your calendar, parses the text, and has an email conversation with you to schedule a meeting. This is now, unfortunately, far more prevalent than broad use cases, but this will change in the near future, I think. Another challenge is that immature technology can lead to customer frustration, and poorly thought-through implementations can lead to PR damage. So you need to predict and take user behavior into account. Let me give you an example, like the major example of this challenge. When Microsoft released its chatbot Tay, as you see here, a few months ago to automatically interact with users on Twitter and help Microsoft's language learning algorithms, it launched what would become a complete public relations nightmare. So this was a bot that was modeled on a teenage girl that was supposed to interact with users on Twitter, and the goal was to learn conversation from users and help Microsoft perform better speech recognition. I think you can imagine what happened. Due to a large number of internet trolls interacting with it very rapidly, it actually became sex-crazed and hateful very quickly. While it was retired within 24 hours, it wasn't retired before making the news. The positive side of the story is that similar bots now being developed, and that have been developed recently by Microsoft, have been rolled out successfully in China and Japan, and help people unburden their feelings, and also can help recommend products and so on. So there's big promise for the future of this tech, and it might become a major disruptor in the not-too-distant future. So while this trend has generated some very intriguing tech that you're starting to enjoy as a consumer, I'm sure, if you have iPhones or Androids, for example, voice commands, most of this may not be directly relevant to your business right at this point in terms of generating the most value in the next 1 to 3 years. The major reason for this is that many of these technologies are experimental and some are niche, or most are niche, I would say. As we go forward to some of the more advanced applications, and we work out some of the pitfalls, I think it's important to keep an eye on the new technology that emerges and look for it when it becomes more mature, so you can interact with customers in a more automated way that's still very simple and very personalized and allows you to collect data and make suggestions. I would say that for most businesses, however, the current relevance of this trend is about 3 out of 5. So keep an eye on it. So now onto the last trend. Again, kind of futuristic. On the other side of complexity, so before, right, I said one of the trends is trying to ask more complex questions. The other question is, what do we do with a huge amount of very, very, very simple operations really, really fast? And how do we combine them together to get insights? I've already mentioned that we have a lot of sensors now inbuilt into common devices, like GPS and cameras and microphones and what have you. Some of you will likewise have heard a number of buzzwords buzzing around about the Internet of Things, where all sorts of objects like lights and refrigerators and drills and lamps and cars are connected to a central network. Of course, this brings its own technology challenges, like what do you do with the massive and expanding volume of data that you can collect from thousands, hundreds of thousands, tens of millions of devices acting simultaneously? Can we analyze things in real time and stream results to other systems for decision making? As it turns out, the answer is, again, getting towards yes slowly. Here, it's important to note that the potential proliferation of sensors isn't necessarily only consumer-facing, or even primarily consumer-facing. The point is that we can continuously monitor the state of objects and their interactions, like whether or not something is being used, which may also give information on who is using it and why they're using it, or whether it will soon be broken or out of service. This is useful for various equipment ranging from elevators to mine shafts to obviously consumer-facing things. It can also positively impact large-scale physical object-heavy operations. For a simple example, let's take a look at the humble trash can. So in the city of Boston, as well as now a number of cities worldwide, more and more of these are appearing. These are solar-powered trash cans that include sensors that deploy a trash compactor when the can fills up, and wireless internet connections, so city workers can check the status of an individual can on a smartphone. Tying back to the other themes, this can lead to better processes, such as faster trash pickup, and thus being more environmentally friendly by optimizing traffic flows and so on as well. For example, the city only needs to empty these things an average of 4 times a week, compared with over 3 times that amount for conventional trash cans. Overall, just a simple change like this, just one very, very, very simple example of a sensor coupled with a process, can save time and money and resources, and can provide useful information about the actual use of a city that was unavailable before. So there are many challenges with the Internet of Things, not all of which have even been discovered yet. There's data volume, so you have many sensors collecting different data in real time, which requires additional technology like data lakes, with all the challenges that I described in a previous trend. And there's data velocity, since you can't store it all, so you need real-time algorithms for finding salient features and transmitting back to the business systems and making decisions sometimes on the fly, decisions that might be too late if you make them in 10 minutes. While there's progress in this, it's not fully mature. Relatedly, there are issues with data quality and support. Remember, these are real objects interacting with real people. That's inherently messy. And if you have multiple messy objects interacting together, that's even messier. So you need to provide ongoing support for interconnectivity and understand this data in a very quick way. Most importantly, I think there are many rabbit holes to go down, and there's not necessarily a clear business need for many businesses, although some are benefiting from this technology tremendously. So I predict that many new types of sensors will become available as prices decrease and that more things will come online. As I mentioned above, however, there will be serious privacy and safety concerns, and regulation will also have to change. However, many businesses are unlikely to start using explicit new sensors in their operations and can likely derive good insights from simpler mechanisms. So while there's great potential in this, in order to have broader usability than just the obvious application, it may require new storage architectures and so on, and there are a lot of challenges. So I would say for many of you, the current relevance score is probably only a 2 out of 5. So, in conclusion, we have discussed 5 major trends in data today: data-driven processes, data lakes, data privacy, human-AI interaction, and the Internet of Things. So what should most of the businesses here actually do about them? As we discussed above, I suggest focusing on improving your own internal data-driven processes first, so you can actually implement insight and focus on privacy, as that's important for all the businesses here. For those who are further along in using data effectively, creating data lakes is a good idea, so you can combine your resources and capture new efficiencies, becoming closer-knit organizations. And for most, but hopefully not all of you, I would suggest just watching the trends of human-AI interaction and the Internet of Things. I think there will be very exciting work done in these two areas over the next couple of years, actually this year as well, and it will be important to see how they evolve and to better understand how they can be used to help your business. So, you have a rewarding day ahead of you today, and where you will learn about the exciting technology that will help you manage workflows, get faster results, and so on. Certainly, I predict the next few years will be transformational, as businesses extract more and more value from new technology and innovation-driven thinking. You'll hear about new research today that will expand the horizons of the questions you ask, and as you go through the day, here's the one thing I wanted you to take away from this talk. Data is a tool. Algorithms are tools. Software is a tool. The trends I laid out above should guide you in your understanding of the exciting world of technology and big data. But what's absolutely required to get started today is your personal commitment as leaders to ask bold questions and follow through on your insights, and to not fear technology, but to use it. Be fearless and have fun. Who knows what you'll discover? Thank you very much, and please enjoy the conference.